In this video, we're going to look at working with Pythagoras inside of circle diagrams. Pythagoras can only be used whenever you have a right-angled triangle. When you're working with circle diagrams, it's possible to form right angles in specific situations. A chord is a line that passes from one side of a circle to another, but it doesn't pass through the centre. So this line BC here is what we would call a chord. I've got a line going from the centre to the edge here, so what I'm highlighting here is a radius. And you'll notice there's a little right angle here. Whenever a chord is bisected, cut into two equal pieces by a radius, it forms a right angle. It doesn't matter where this chord is, it will always have a radius that can split it in two equal pieces and form a right angle. The size of the circle doesn't matter either. If I make the circle bigger or smaller, I still have this sort of setup here. A chord being cut into two equal pieces and forming a right angle with a radius. So the real skill in these problems is knowing where to draw your radius to help you form right-angled triangles. So here's a fairly routine question here. I've got a circle has centre C. The radius of the circle is 15 centimetres. The chord AB is 25 centimetres long. Find H, the height of the blue segment. So notice H is going straight up and down the way here. So it's encouraging us to drop a line like this and meet AB at the halfway point. So I'm going to take a line and drop it down. And I'm going to cut AB into two equal pieces and form a right angle. Pythagoras is all about working with right-angled triangles. So I'm going to draw another radius in here. I know this distance here is going to be 15 centimetres because this distance here is from the centre to the edge of the circle. So that's going to give me a bit of the height. What I need to do now is find this distance, so from the centre down to the chord. We can't assume that the radius has been cut in two pieces here because that's not how this fact works. It's the chord that has been cut into two equal pieces. So I'm going to sketch out this triangle at the side and fill in some information. AB has been cut into two equal pieces. So this distance here, that's going to be 12.5 centimetres. This length here is the radius. The radius is 15 centimetres. So we were told that information in the question. It wasn't drawn on the diagram for us. The whole point in this question is checking that we know where to draw it. This is an unknown, so I'm going to mark it with a letter. The letter H has already been used, so I can't use that. I'm just going to fall back to the old classic X. I can find the length of X by using Pythagoras because I've got a right-angled triangle. X squared is 15 squared minus 12.5 squared. I know it's minusing squares because X is one of the short sides. He's touching the right angle. So typing that into my calculator gives me 68.75. That's X squared. So to find X, I take the square root of that. Again, just using my calculator, the square root of my answer is 8.291 with a few more digits after that. Now, I could have been asked to do a couple of things in this question with this diagram. The classic example is giving you a diagram of a water pipe and asking you to find the depth of the water. If you've been asked to find the depth, you could take the radius of 15 and subtract the value we've just found. However, we've been asked to find the height of all of this. So, to find the height, I need to take my value of x, and I need to add on this line here, which is another radius. So my height is going to be my radius plus x. My height is going to be a radius of 15 plus this value of x. That's going to give me 23.291, which I can round off sensibly. I'm going to round this to 2 decimal places. 23.29 centimetres to 2 decimal places. Next one. This is also a routine question. We've got a circle has centre O. The radius of the circle is 6.8 metres. The width of the blue segment is 3.2 metres. Find the length of the chord QR. So again, we have got a distance here. So that's encouraging us to drop a line, and that's going to help us form a right angle. So if this line bisects the chord, it is going to form a right angle. To form a right-angled triangle, I'm going to need to draw a radius in here. Alternatively, I could draw a radius in there, and that's going to give me an identical, a congruent triangle, same shape and size. I'm just going to pop it in the top there though. Now I've got my right-angled triangle formed, I can pull it out from the diagram. If you've already drawn this diagram, it's not vital you redraw a triangle. However, I find it's quite useful, as this diagram can get quite busy when you're adding things to it. This line that we drew in for ourselves is a radius. We know the radius is 6.8 metres, so we were told that already. We've been asked to find the chord QR, so we know nothing about it other than it's been split into 2 equal pieces. So we don't know the length of this. We have to give it a letter. So I'm just going to call it X again, because the letter X hasn't been used anywhere in this diagram. This one is part of a radius. Again, we can't assume the radius has been cut in half. It's the chord that gets cut in half. However, if all of this is 6.8 and this bit here is 3.2, this bit is going to be 6.8 minus 3.2. That's going to be 3.6. So this length is 3.6. I can add that into my diagram. I can use Pythagoras again. X is touching a right angle, so X is a short side. So I can do the big square, take away the small square. I go and type that into my calculator and get 33.28. And to find the value of x, I'll take the square root of that. It is 5.768. Loads more digits after it. That is giving me the length of this line. Because the chord QR has been bisected, I need to take this value, which I have just figured out, and to find the length of QR, I need to double x. So that means QR will be 2 lots of 5.768 blah blah blah, which is equal to 11.537 blah blah blah, which I'm going to round off sensibly to 11.54. So I've chosen to round to 2 decimal places, and I've popped my units in as well. At first glance, this third and final question looks as routine as the previous 2, but once we get stuck into it, it'll become clear it isn't. However, our starting procedure is identical. We've got a circle with a centre K, the chord ST is 12 centimetres long, the blue segment has a height of 9 centimetres, and we've been asked to find the radius of the circle. So this line going up and down the way, it's encouraging us to draw a line up and down the way there. to bisect that chord. So who am I to argue? I'm just going to go ahead and do that there. By drawing in that line, I can bisect the chord ST, cut it into 2 equal pieces, and form a right angle. I've got 2 out of 3 sides of a right angle triangle, so if I draw on an extra radius, I can form a full right angle triangle. I can sketch that over at the side. I'll extract it from my diagram. The chord has been bisected, cut into 2 equal pieces, so this side is 6 centimetres. We've drawn in a radius. We've been asked to find the radius. So I'm going to use the letter R there, because that's what we would typically use to represent a radius. We've got this line here. Now, this is a little bit more difficult. We don't know how long that is, so I'm just going to pop in an X there. 6 and X are the short sides, so I could say 6 squared plus X squared equals R squared. But the problem I've got is I have got one equation with 2 variables, and that is impossible to solve. If I've got an X and an R, I've got no way of figuring out what they are. The only way I can solve this problem is if I have got one variable, one letter. I have been asked to find R, so this X is really the problem. So I'm going to get rid of X from my equation there. I know this line here is 9 centimetres. I know this bit of the line, where I've added in these arrowheads, is the radius. So this bit, if I wanted to figure out its length, I would do 9, subtract the radius. So I'm just going to write that down as a little algebraic expression. 9 minus R. That has gotten rid of the problem of having 2 different letters. I've now got R on both of these. So 6 squared plus 9 minus R squared equals R squared. Still using Pythagoras, 2 short sides squared added together equals the large side squared. And more importantly, I've only got one letter here, so I'm going to be able to solve this. I've got some brackets and some number work to do, so I will deal with that before I can start solving it. 6 squared is 36, plus I've got some brackets to multiply out. Now, I don't care how you multiply out brackets. You might break brackets, you might use a grid, but multiplying that out will give you 81 minus 18R plus R squared. And that will equal R squared on the right hand side. What we have to do whenever we've got a quadratic equation is you have to bring everything over to one side, make one side equal to 0, and then factorise to find some answers. That said, I'm sure some of you might have noticed that it's actually going to work out a little bit easier than that. Before I do any of that though, I'm going to tidy up these number terms. 36 plus 81, that is 117. I'll still have the minus 18R and the plus R squared, and that's still equal to R squared. I am going to take away an R squared from the right hand side, so I'll do the same to the left. This will leave me on the right hand side with nothing. On the left, my 117 will be unchanged, the minus 18R is unchanged, and R squared minus R squared will leave me with no R squareds. So that's actually dealt with the problem with the squares. I'm not going to need to factorise here. So I want to get the R's on their own, so I'm going to add 18R to each side. That will give me 117 equals 18R. I don't want 18R, I want a single R, so I want to divide by 18. Because I've set this up like a fraction, I can simplify it like a fraction. 117, 117, that's in the 9 times table. I just quickly added up the 3 digits, and because that came to 9, I know this is divisible by 9. So if I divide the top and bottom by 9, I'm going to know R equals 18 divided by 9 on the bottom. That's going to give me a 2. 117 divided by 9. 10 nines are 90, and that leaves me with 27, which is 3 nines. So 10 and 3 is 13. That's actually a fraction in its simplest form, so I would get away with leaving my answer like that, because 13 over 2 doesn't go any further. However, there's nothing to stop you going at 6.5 centimetres by actually dividing the 13.2. So, while this was a less routine question here, it was the same technique as before. Splitting the chord into 2 equal pieces with a right angle and adding in some extra radii